Thanks to you joining us here for the first workshop on linked data in Industry 4.0. Perhaps let's let me quickly introduce myself. I'm Thomas Moser from Vienna, from Fachhochschule St. Pölten. And my colleague here is Stefan Huppe from IOT Austria. And we have the honor and pleasure today to give this short workshop to you. Perhaps let me start what you can, or why you could be here, or what could be some of the keywords that attracted you for coming here. I just named some of the today's buzzwords that hopefully we will in some kind tackle today in this session. So we have for sure Industry 4.0, we have linked data, we have Internet of Things, we have smart engineering, we have cyber physical systems, we have big data, so we really have much more, like all of the buzzwords. So this was just making fun of the current trends in scientific and industrial community. So let me start with the most important thing for you, some administrative issues. So you can all of the colleagues, we do not have mobile internet here in Vienna, can use the Wi-Fi from the conference. You can see the SSID and the login data here. For sure, if you're interested, we're also handing around a participant list where you can where you can sign your name and perhaps email address. If you're interested in topics related to Internet of Things or Industry 4.0, can you see in the background the slides, because I don't know whether there is a bigger window to present or something like this.
It's okay.
It's okay?
Yeah.
Perfect. And also, if you're here for the Semantic conference, I see some of you are already wearing the badges. So there's also after this workshop the possibility to register already today, because they told me tomorrow morning probably will be a bit crowded. So if you have the time, you can today afterwards register. So we have a very packed agenda for this short workshop. We have now already the welcome and introduction part, which will be given by myself and by Stefan Huppe. Then we have two, let's say, expert talks from two people, one from academia and one from industry. They're talking about their sides or their ideas about Industry 4.0 and linked data. Then we have this statements and discussion session where we wanted industrial partners to present their very brief use cases, just what they are currently doing in the scope of Industry 4.0, what their findings or their opinions about this topic are, and also this should be a good point for starting short discussions. And then for sure we have some summary and closing and next steps. Okay, but let me start with a very brief introduction of Industry 4.0, which is rather nice because last week we started our new curriculum in St. Pölten, where we also asked our students, so before they learn anything new from us, we wanted to know from them what they think about Industry 4.0. And this was really nice for us, because in principle we do not have to teach them anything, because they all know right now what Industry 4.0 is. And yeah, it's a good job. So it's an easy job for me, and I just wanted to show you some of the flip charts that the students draw in the session, what they think about Industry 4.0. I excuse myself because this is in German, but I think most of the
Do we get the slides?
yeah most of the terms should be self-explaining. So they're talking about digitalization or linked production or human-machine interfaces, about quality assurance, about the optimization of production, then about better usability, secure communication networks, for example, and also about flexible production, about methods and tools, and about integrated production, and about logistics and optimized maintenance. So in principle, we have a lot of topics here which are really in the core of what we think that Industry 4.0 is. What we then did in our first lessons is that we asked also beforehand experts what, in their opinion, Industry 4.0 is. And so we asked, for example, people from the Fraunhofer Institute in Stuttgart, give us an example how Industry 4.0 could look like, how the Industry 4.0 working place of the future could look like. Okay, and this looks a bit futuristic that you have here tools that support the workers in their doing, but in principle it is that all of these machines or all of these devices or working cells communicate with each other in order to present the capacity, the orders to the other machines, and the worker himself is supported by the machines, and in principle it's more a supporting work or an overlooking work than in really an actual industrial work, like working on a conveyor belt and doing kind of stuff. Then, for example, we also asked people at the University of Technology. Here we have it on a more technical layer. We have like manufacturing execution systems and ERP systems on top of them. And in principle, in the future, it should be that all of this is like a circle, that you have the order coming in, which gets simulated then it goes through the ERP, through the MES, down to the machines and back up. We have something like production cells, flexible production cells, which, for example, are made at EFA Technical Communication. Here we have like relay communication that goes also from the MES down to the machine itself, using, for example, OPC-UA as an interface for this, and back up. And what's also interesting, because this is something that is really new, is additive manufacturing, like 3D printing, for example, which in the future, for example, can be used for production of dental prostheses or stuff like this in the medical sector, where you really design the product first on a virtual model and then really create it out of the work stuff, so that the piece comes out at the end. So you now have really seen a lot of stuff. So it's very, very hard to understand for people if we're talking about Industry 4.0, what really is this. So I think the easiest way we can say it's Industry 4.0 is a trend. It's not a technology itself. So it's a trend. So what kind of trend is this? So it's a trend that is, we can see through all of the examples, it's a trend that is based on the intensive interdisciplinary interaction of machines, then a set of machines or a plant, and over the plant, a lot of plants, and then companies over these plants. And the basis for all of this is the digitalization of work processes, production processes, and at the end, for sure, also of the business processes. So the trend is supported, and that's also nice that we have this industrial use case session later in this workshop is supported by the transformation process inside the company. So you cannot expect that a company just say, okay, now we are doing Industry 4.0 and we're doing it all from the scratch, and we haven't done anything like this in the beginning. So the companies really need to have a transformation process so that they can slowly change digitalize their processes in order to be able to follow this Industry 4.0 trend really. And perhaps the most important thing is that this trend is for industry, for suppliers for sure, but also there will be a lot of new business opportunities or business models for service providers that provide some of a very specific functionality in this Industry 4.0 field, and can therefore build up new companies inside this area. So I already told you this. We started last week with a new curriculum, which I do not want to introduce to you in detail, but just 2 or 3 short slides on this. So this curriculum is called Smart Engineering of Production Technologies and Processes, and we have like 2 main focus points. On the one hand side, we have the smart manufacturing focus point with human-machine interactions and shop floor IT and intelligence machines. And on the other hand side, we have the main focus on smart automation, where the main topic is industrial security and interconnected and distributed production processes. And what's also new in this curriculum, and this is really new for let's say, most of the part in Austria, that we also have like practical phases inside this curriculum where our students really go to one of our 25 company partners and do their practical work there during the term. So they have first to learn a bit of theory, then they go to the companies, do some practice, some practical work, then they come back and have some reflection phase where they can see what they have learned, how they have applied the new findings. Then there's also this famous saying by Confucius that if you really do something, then it's easier for you to remember it, other than when you just get it, when you just read it or when you just hear about it. And so that you know who are our partners. So we have here really an extensive network of partners. Some persons of these partner companies are also here inside this room, which is nice. And yeah, we started last week with 30 people, and we are really looking forward for the next weeks and months and years. So this was a very, very brief introduction from my hand, and I want to hand over to Stefan for his introduction.
Okay, welcome. I have to switch here to technology.
And perhaps in the meantime I hand around this participant list. If you're interested, it's no obligation.
So,
just fill it out.
Let's start the show. So, I will talk about the Internet of Things and linked data. I'm sorry for that some of my slides are in German, but I think you will be able to understand them. So, my name is Stefan Hupe. I'm a fast business hacker and business mentor. I'm advising companies and politicians about the digital transformation. And I'm the founder and co-organizer of IOT Austria, the Austrian Internet of Things Network, and IoT Vienna, the Internet of Things group here in Vienna. IoT Austria, the Austrian Internet of Things Network, was founded in May last year and currently has more than 2,200 participants. Our target is to support the development of Internet of Things in Austria by offering a platform where people, companies, scientists, and other people who are interested in the topic of Internet of Things have the possibility to meet each other, to connect them, and to share their knowledge, their experience, their resources, and their contacts, starting to collaborate. Because we are convinced that collaboration with other people, with other companies, is the main key factor for success in this area. We are offering here in Vienna monthly talks, the IoT talks, and 2 weeks later workshops where the people can make their own hands dirty in some topics of the IoT area. We have groups in 8 cities here in Austria, so we become bigger and bigger. We are asked by a lot of groups here in Austria to join our community. And we have some special events for you. One I've added just a minute ago is the Digital Construction Think Lab, which we will make together with the digital creators, where we bring together people from art, from film, from painting, with technical guys, hackers, businessmen. So both can describe their ideas and their needs, and both groups can try to find together a solution. We will have a hackathon inside, and we will do it in collaboration with the NASA. So it's really, really interesting stuff. And the second thing is, our next big Internet of Things event on the 4th of November in Museumsquartier Wien, where we will have the Austrian IoT Day. It is an IoT conference, IoT talks, special industry 4.0, an IoT academy with a lot of workshops, and an IoT exhibition, and in the evening, an IoT party of the community. You are all invited to come to this event because it is for free, and we have space for about 1,000 people. So if you're interested in our work, go to the internet, iot-austria.at, or on Twitter, IoT Austria. So I start with my talk. The Internet of Things contains two words, the Internet and things. So the main question is, what the hell is a thing? The thing is any physical object, and you add there some electronics, a little computer, it's a brain, it's a memory, some sensors which are able to feel inside the object or to feel what happens in the interior of the object. Some actuators which make this thing to act, to do something. And last but not least, the capability to communicate. And that's the most important thing for the Internet of Things, for a smart device to be able to communicate to other things or to people. An example here is this cooking pot from Fislo. It has a temperature sensor inside to measure the temperature of the content, and has a Bluetooth connection. So you can sit in your living room on your couch and get notice when your potatoes are ready. So, and what is this thing? Should I give you some examples? No? Okay, fine. Okay, a thing could be your shoes, the dolls, egg holders, some sex toys, lamps, trucks, ships, trousers, robots, dog houses, cars, washing machines, socks, rats, humans. Every physical object can be a thing. And yes, you have seen right, also human. In Sweden, they are implementing the people RFID tags, so you'll be able to communicate with other physical objects. Everything can be a thing. And what is the Internet of Things? A theoretical description. The Internet of Things is a dynamic global network infrastructure with self-configuring capabilities based on standard and interoperable communication protocols, where physical and virtual things have identities, physical attributes, and virtual properties, use intelligent interfaces, are seamlessly integrated into information networks. Can I write a test? Does anybody understand the definition?
No.
Okay, make it a simple example. We have a thing, we have another thing, and both things are able to communicate. Hello, hi, yes, here I am. That's it. We have different kinds of communication ways. Some things may communicate directly. Other things are using other things for the communication process. Sometimes we need a translator for the communication from one thing to other things because they don't speak the same language. or we will use the cloud, the internet for communication. So when I touch here the light switch in Japan, the light will go on. A real example. Here we have a balance, and there is our cooking pot. And when you put this cooking pot on top of the balance, the pot tells the balance its own weight. So the balance is able to make a error. 0. If you then search a recipe on the internet for the meal you want to prepare, the iPad sends the information that you may need 200 milliliters of milk. And the iPad tells you, please fill in some milk. More, slow, stop, just enough. Because the balance has told the iPad the weight. And when you then put the cooking pot onto the stove, the pot knows that inside him is 200 milliliters of milk. And the stove chooses a temperature profile for heating the milk without burning the milk and without that the milk is going over. Okay? So if you have such a structure locally, you can talk about the local net of things. And that's not so rare. Look at this packaging machine, and inside the packaging machines are a lot of components, things that communicates to each other. Everybody who's working in the industry for machine control systems knows such structures. And if you connect more machines together, you have again a local network, because the companies are not interested in a connection to the global internet. If you do it over the internet, over the cloud, you have a global net of things, the internet of things. And you may have noticed that we could have different system structures. Central structures, all devices are talking to a capital, to the cloud, or you have decentralized mesh systems, or you have a combination, the domain systems. Here you have the domain, and there you have the second domain, and they are connected by control points. The control points are the most important things of the new business models. Apple, Google, Facebook are claiming these points. So let's talk about collaboration, or Zusammenarbeit in German. If you think the Internet of Things is you have a thing, a smart device, and you have a smartphone, and you have a user, that's the Internet of Things, yes? Who agrees?
I agree.
No, it's bullshit. That's not the Internet of Things. Every startup is developing a nice device for connecting to a device, and so the user has to interact with the device. No, that's not the Internet of Things. Because the things should do their job themselves without an interaction with the user. Such an example, a smart toothbrush connected with your smartphone, which tells you, have you just polished your tooth enough and long enough, and send this information to your health assurance. Maybe an Internet of Things, but I don't like it. Second possibility, you have a lot of things connected to the cloud, and you have a big data analytics systems. Is that Internet of Things? No, that's not Internet of Things. Because they are thinking in the kind of data acquisition. Collecting as much data as possible, send it to the global cloud, and control everything. And you, an organization, would love this idea. And I also know a person who will love this idea. Also here in Austria. So that is not the Internet of Things, because you haven't the collaboration of the things. Self-organized and decentralized systems are the basis of the Internet of Things. And the Internet of Things should do the work for the people. In Germany we have the fairy tales of the Heinzelmännchen. Who knows the story? Little guys who are doing your job and you can stay free at home. So we have this collaboration of things. Niklas Luhmann has called them emergent systems, self-organizing systems, or derived from the artificial intelligent multi-agent systems. And it's an idea that we have stolen from nature. I'll show you how it works. This bionic end shows the concept of the Internet of Things. Independent, smart systems which have the capability to communicate to other things and to collaborate, to solve tasks together. So let's talk about the communication. So, communication. We have two things that want to communicate together. How does it work? First, one thing has to get aware there is another thing. Hello, do you see me? Yes. Second, I have to get in contact. Third, we have to find a common language to talk. Chi parla italiano? Molto bene. Allora facciamo in italiano, sì?
Sì.
Okay. Wir können es auch auf Deutsch machen. Wir müssen halt eine gemeinsame Sprache finden. And that's the same task for the things. Find a common language. Currently, the developers are tell the devices what kind of language they have to use. But in future, the systems have to find a way by themselves. Then they have to get knowledge. Who are you? What are your capabilities? What we can do together? And then they start the communication and starts to understand what the other thing wants and what the other thing tells you. And last but not least, we can start with the cooperation. How can they communicate using what kind of medium? Well, they can use optic systems like barcodes, QR codes, or gestures for communication. They can use acoustic sounds, beeps, or speech, voice for communication. They can use electronic systems like 24-volt systems, serial buses, the Ethernet, whatever you can imagine. You can use wireless systems like RFIDs, NFCs, Bluetooth, 6LoWPAN, Wi-Fi systems for communication, magnetic systems, or haptic systems, communicating by touch. All these ways are possible and are used from IoT devices, mainly electronics and wireless systems, but also other systems are existing. Who knows an optic IoT thing using an optic communication? Nobody of you have been in the supermarket? Every piece in the supermarket has a barcode on top. It's the first way of communication. Over the tin you have in your hand with the cash desk system. So easy. So you can use different varieties of protocols, MQTT, OPC UA, CoAP, RAS. There are as much communication protocols as you can imagine. Every day there will be 2 new more. These are some of the most popular systems. But we have some problems. Here I have a photocell. And what does this photocell do? Well, it's giving me some signals. Low, high, low, high, low, high, low, high, low, high. Very boring. But what does it mean? What does it mean? I have no idea. If I don't know the context, I can't do anything, nothing with this data. The same with a temperature sensor, 4.3 volt. What is it? Well, maybe 30.4, but what is this? Oh, 30.4 degrees Celsius, that might be a temperature. Give data a higher value by adding a context and a description, so you know what you can do with this data. And that is the topic of linkage data. Here's an example for getting knowledge of such sensor. If I ask, what are your capabilities? You can answer me, well, I have the idea 1, 2, 3, 4, 5. I'm a photocell banger, and we have some documentation, and I have a supplier, and we have an order number. For this example, I used JSON-LD instead of RDF because you can read it a little bit easier. Not so many tags. In this file, context.json stands the description of what this keys, what's the meaning of this keys. And here you have an identifier, which is an abbreviation for a URL, mynet.com devices sensor 1, 2, 3, 4. Here I have a link to the documentation, readable for humans, not for machines of this kind. Here I have a link to a supplier, where I can get more information about the supplier, where can I order this stuff, how much does it cost, and and an order number. So 1, 2, 3, 4, 5, 6, 7, and one more again. And this is Here I added some more informations. I have changed the type from photocell binary to photocell door position. That means I have a possibility to describe this location. It's the front door of this building. And I have the possibility to describe value high means the door is open, and value low means the door is closed. When I then get a signal from the sensor, I have the information about the idea, the photocell, I have a time stamp when the signal was created, and I get a value, 1 or high. If I use the description photocell dot door position, I get a value door closed. So I know what this value 1 means. I can do the same with the temperature sensor. Here I have a type temperature.si.Celsius. So this value has the unit Celsius. Now let's play with big numbers, really big numbers, with trillions, to give you a feeling about what will happen to us. Some guys think that in 2020 we will have 2 billion of internet users, which use currently at the same time the internet. And in 2014 we have installed 4 billion IoT devices. Some guys think that in 2020 we will have 215 billion IoT devices installed. Well, some of the guys think that might be 15 billions. Others said 30 billions. Some others again, 100 billions. The number doesn't matter. What is important? It's the relation. In 2014, we have had 1 billion smartphones in the world. We have had in 2014 more IoT devices active than smartphones in the world. In 2020, much more IoT devices. So we create a lot of data. And we are in a data rush. Everybody is thinking big data and artificial intelligence, and a lot of data will give us a possibility to have a good look into the future. And we can decrease risk, and we may have better decisions. We can make decisions before people know about their needs and can fulfill these needs. Information has become the 4th production factor, aside of working, resources, and capital. And data have become the new gold. That's the reason why there's this big fight from large companies to protect their claims. But data without common context have less value. We need a context to give the data value. Let's have a look at the network traffic. A photocell sends you 1 bit a day or 1 bit a milliseconds. That may vary. A packaging machine, like I have shown you, produces 10,000 data points a second. That's 9 megabyte raw data an hour. Soap dispensers from Harklight now are producing 7 terabyte a day. An airplane, 17 terabyte per hour. And the LHC, the Large Hadron Collider, produces 500 exabyte a day. Remember, 1 exabyte are 1 million terabytes. And these are numbers for raw data without context. Make this calculation. think about our network traffic. Adding context to data blows traffic up. Instead of this, we will have that. And when I travel by train from Meidling to Mitte, 5 stations, I have more than 5 interruptions in a phone call. How we will make the Internet of Things happen with our currently telecommunication infrastructure, and how we will make linked data happen in the Internet of Things. I don't know. So, if you are interested in more, you are invited to support our group, to join our group. We want to open doors for people and companies to be successful in the Internet of Things. Remember our event in November. And yeah, thank you very much. One question I have. Who has stolen something sometimes? I will show you a little video. The Internet of Things will bring us at home a lot of comfort. Really a lot of comfort. And a lot of advantages, especially if you are a thief.
Curtains, lights, doors. It even unlocks my car. And the only one with access is me.
And that tells everything about security in the Internet of Things. Thank you.